All right, for our second video, we're going to talk about some coordinate proof information. This should be review from before, so should have already had notes similar to this. We're going to go over it one last time, given 2 points, x1 and y1, and the other point x2 and y2. If we want to know the distance between those 2 points, we just plug it into this distance formula. And remember, that comes from the Pythagorean theorem. D squared equals this amount squared plus this amount squared. So to get d squared alone, or just the d, we would take the square root of both sides. That's why there's a square root on this one. Also, from now on, if the points are on a straight line, on the same x line or the same y line, go ahead and just count the spaces. That'll show us the distance between those two just by counting over. Also, one we haven't used before, I think I've talked about it a little bit before though, use 3, 4, 5 right triangles. Here's what I mean by that. Anytime you have a triangle where this line is 3, this line is 4, and this is a right angle. Okay, and again, I think I've mentioned before, carpenters use this a lot when they are measuring things. This last piece, so this line, has to be 5. Again, whatever unit we're using, if this is 3 feet, 4 feet, this would have to be 5 feet. 3 centimeters, 4 centimeters, this has to be 5 centimeters. As long as this is 3, this is 4, and this is a right angle, this has to be true. Okay, so we're going to use that information to say from now on, if we can find 3, 4, we know this point to this point has to be 5. That'll come up in at least one of our examples today. But go ahead and use that as a fact from now on. Midpoint formula. Again, given these 2 points, the midpoint or the middle in between them would be at the spot x2 plus x1 over 2, y2 plus y1 divided by 2. Okay, so that would just give us 1 point. Okay, remember you take these 2 x values, find the average of them. That's our new x value, the x value of the middle piece. Take these 2 y values, y1 and y2, find the average of them, and that's the new y value of the middle point. Also, again, if the points are on a straight line, go ahead and just use the exact middle. If we have a point here and a point here and they're 6 away, the middle is just going to be 3 away from each of them, right in the middle. Slope and relationship of slope to parallel and perpendicular lines. This is the formula for slope, y2 minus y1 over x2 minus x1. That would be the slope of those, or between those 2 points. Again, if you want slopes of something parallel to that, it would be the same exact slope. So m equals m, they have to be the exact same for those lines to be parallel. If you want the lines to be perpendicular, they'd be the opposite reciprocal. So if I found the slope of one line to be positive 2 over 3, then a perpendicular line would have the slope of negative 3 over 2. Okay, so again, in a general form, you might say if the slope of one line is m over g, then the perpendicular line would be negative g over m. These two switch, and the sign changes as well. Also, finding slope, again, using the diagram, if you can look at the picture, just count up how far up or down you go, and the spaces left or right. And I'm actually going to take this out. Don't count left, always count from left to right. So how many spaces are you moving right? Okay, just like when you're reading a book or when we're reading something like this, slope and relationship of slope to parallel and perpendicular lines. We read it from the left to the right, always. So always look at your points as though you're going from left to right. All right, let's look at one example using our new information here then. What is the length of the mid-segment? Okay, we have these 4 points, 0, 0, 8, 6, 17, 6, and 20, 0. Like I said, because this point and this point are on a straight line, they both have the y value of 6. So there, if this was a grid, we'd have a straight line going here. Instead of plugging these into the distance formula, go ahead and just count them over. How do I go from 8 to 17? Or if I had all the boxes, I would count 1, 2, 3, 4, 5, 6, 7, 8, 9. From here to here, it is 9 spaces. We can just count it off. Okay? That only works if they're on a straight line. For one like this, you can't use that because this is not on the same grid. We can't just count over and say, oh, that's up so many spaces. Exactly. We don't know exactly how many it is, right? Because it's not on a straight horizontal or vertical line. You can only do it when it's horizontal like this or exactly vertical. But for this one, we can, because it is horizontal, so we can say it's 9. For this one, from 0, 0 to 20, 0, again, it's on the same horizontal line here. So instead of using the distance formula, go ahead and just count over some spaces going from 0 all the way up to 20. That would be 20 spaces away. So this distance is 9, this distance is 20. Remember, to find the mid-segment of a trapezoid, it's always going to be the average of these two pieces, 9 and 20. How would we find the average? Add these two up and divide by 2. 9 plus 20 divided by 2. In the end, that would come to 14.5. So this mid-segment, we can say, is 14.5 feet or inches or centimeters or however many, whatever unit we're calling it, it's 14.5 of those from S to V. All right, in example 2, if we need to identify this quadrilateral, so on the picture here, we have the grid all drawn out. We have our 4 points making a quadrilateral. We need to identify it as specifically as possible. So, things we're going to do for this. First off, we're going to look at the slope of the lines. If this slope from A to B is perpendicular to this slope from B to C, we would have a right angle there, and that would tell us a lot of information. That'd be really helpful. But we can't say for sure that it is or is not a right angle until we've actually found their slopes. So the first thing we're going to do is find the slope of each of these lines. So we're going to start with A to B, so going from here to here. Now again, we can always use the midpoint formula and say 9 minus 3 over 1 minus negative 1, and we would get 6 over 2. We can do it that way. Or we can just count. How far up are we going? 1, 2, 3, 4, 5, 6. How far to the right are we going? 1, 2. So we would say our slope is 6 over 2. Now, we can always reduce that to 3 over 1. Or we can reduce that to anything divided by 1 is just 3. So we'd say the slope from A to B is 3, or 3 over 1. Get rid of those points. Let's check now D to C. Actually, I'm going to use green for that one. So again, going from here to here. Like I said before, we can take 3 minus negative 3 over 3 minus 1, and we'd get 6 over 2. Or we can just count from this point to this point, again, reading from left to right. We're going up 1, 2, 3, 4, 5, 6, and over 1, 2. So either way, we'd get 6 over 2, which we can reduce to 3 over 1, which we can reduce to 3. So we have the slope of this line, A to B, and the slope of this line, D to C. 2 down, 2 to go. Slope of A to D. So going from here to here. Remember, again, we always read left to right, and A is further left than D is. So we're not going up anymore, we're going down. Okay, so starting here, we're going down 1, 2, 3, 4, 5, 6, and to the right, 1, 2. So instead of positive 6 over 2, it's negative 6, because we're going down over 2. And this bottom number will always be positive as long as we're going from left to right. Because moving from left to right like this, your x value is always getting bigger. It's always getting more positive. So this one would always be positive. Looking at our slope here, negative 6 over positive 2 is the same as saying negative 3 over 1, which is the same as saying negative 3. So we have 3 of our slopes. We'll get the last one here going from B to C. Again, we can use 3 minus 9 is negative 6 over 3 minus 1 is 2. So we can get it that way and do negative 6 over 2. Or we can start here, the lefternmost spot, work our way from left to right and say we're going down 1, 2, 3, 4, 5, 6, and to the right 1, 2. Down 6 and over 2. That would be our slope. We can reduce it to negative 3 over 1, or just simply negative 3. So now we have a slope of each of these lines, or each of these sides. Looking at that information then, A to B and D to C have the same slope, meaning that those ones, A to B and D to C, are going to be parallel. Same thing, A to D and B to C have the same exact slopes, so those ones would also be parallel. At this point, given this information, we have a parallelogram. We have 4 different sides here that are all parallel, or at least parallel with their opposite side, so this would be a parallelogram. Okay, properties of a parallelogram, we know for sure, just by saying this is a parallelogram, this line is going to be the same as this one, and this line, I'm going to do tick marks, is the same as this one. So we don't even really need to do the distance formula to prove that. To check to see if it's any specific kind of parallelogram, we need to check and see if these angles, just even one of them, if it's a right angle. The only way to check that would be is if this slope was the opposite reciprocal of this one. So let's look at that. If this was 3 over 1, a perpendicular one would be negative 1 over 3. Is that what the slope of any of these two lines is? No, these are negative 3 or negative 3 over 1. So it is not going to be perpendicular, meaning these are not right angles, which is very helpful because that means this cannot be a rectangle because it doesn't have right angles, which means it also can't be a square because a square would have right angles as well. So the last thing we need to check is if it is a rhombus. And the only way for it to be a rhombus would be if this one was the same as this one. Right? If this is the same as this, that means all of them are the same. So for that one, we will need to use our distance formula from A to B and from B to C. So the distance from A to B, again, we're just plugging in all of the points. 1 minus negative 1 squared plus 9 minus 3 squared, square root of all that. 1 minus negative 1 is 2, so we have 2 squared. 9 minus 3 is 6, so we have 6 squared. Well, 2 squared is 4. 6 squared is 36. So we have the square root of 4 plus 36, which we can simplify to the square root of 40, which is about 6.325. That would be this one, A to B. Now we need to find B to C. So again, plug it into our distance formula, 3 minus 1 squared plus 3 minus 9 squared, and the square root of all of that. That's where we'd start with. Simplifying that down, we'd get the square root of 3 minus 1 is 2, so we're looking at 2 squared. 3 minus 9 is negative 6, so we're looking at negative 6 squared. 2 squared is 4. Negative 6 squared, so a negative times a negative would become a positive, so this would become 36. 4 plus 36 is 40, and the square root of 40 is 6.325. So these are, in fact, the same exact length, meaning this is the same as this, is the same as this, is the same as this. These are all parallel, or at least the opposite ones are parallel. These are all congruent, which means since all opposite sides are parallel and 2 consecutive sides are congruent, this must be a rhombus. Last one for this video. We'll quit after this one. A quadrilateral has the following 3 vertices. A is right here at 0, 0, B is right here at 3, 4, and C is at 8, 4, over 8 and then up 4 here. Find the 4th coordinate that will make the quadrilateral A, or an. First off, we want to make it a rhombus. Remember, for it to be a rhombus, all of the sides have to be parallel to each other, or to their opposite, and they all have to have the same length. So this is a case where our 3, 4, 5 triangle will come in handy. From here to here is 3, here to here is 4, meaning that this line, I'm going to draw it in, how about in blue, this is going to be 5. I don't even necessarily need to do the distance formula. 3 here, 4 here, this has to be 5. If that is true, then I can also, again, just count over from here at B. I'm going over 1, 2, 3, 4, 5 to get to C. I want blue again. This one is also 5. Again, I don't necessarily need to use the distance formula. Because they're on a straight line, I can count those off. So if these are already the same exact lengths, I just need to find a line that's going to be parallel to this one that is also 5 lengths away, and that'll be my last spot. So this is a straight line, or a horizontal line, so I need a horizontal line over here that is 5 lengths away. 1, 2, 3, 4, 5. Right here would be my last point. And I can even draw it in and show that that would look like a rhombus. Here to here, here to here. All of these lines are going to be parallel. All of them are congruent. They're all 5 spaces long. Again, we can do a double check. Here to here is 3. Here to here is 4. This is a right angle. So this one has to be 5. So all of these are 5. Kind of helpful when you have the 3, 4, 5 right triangles. So what is this spot that would make it a rhombus? Well, we would call that the point. Our x value is 5 over. Our y value is 0 up. So 5, 0. Perfect. We don't need this one anymore, or, oops, we do need all of that, just not this blue line. And we don't need that dot. We need to make an isosceles trapezoid now. Again, an isosceles trapezoid, this would have to be parallel to a line down here, and the other line that we draw from C coming apart has to be just as long as this one, has to be 5. Well, again, we've got the properties of 3, 4, 5 right triangles. So we start from here and we count down 4. 1, 2, 3, 4, and over 1, 2, 3, meaning that this line that we draw in has to be 5, again, units, whatever we call our units, long. This is 5, this is 5, this is 5. Then our last line, again, we just need it to be parallel. I'm going to use red for that one. Would be parallel to this line up here. So this would be an isosceles trapezoid. What is the point over here that makes it that way? I'm going to use purple. Which point would make this an isosceles trapezoid? Again, our x value is 11, our y value is 0, so we'd call it the point 11, 0. And the last one, we need to make that a kite. The kite is going to be a little bit trickier. Get rid of all of these ones that we don't need. Remember, for the kite, think about the diagonals. On a kite, we would have these two diagonals going from here to here and here off to some other point, some next point somewhere that we don't know what it is. But we know that this diagonal, the one that I'm holding on to, is going to have to be a perpendicular bisector of this cross diagonal right here. So I need to draw it in somewhere that makes it perpendicular. So if I get rid of that extra one that I drew in, let's look at this diagonal and say, what is the slope of this one? Because for it to be perpendicular, then we just need to find an opposite reciprocal slope. So counting from 0, 0 all the way up to 8, 4, we're going up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8. So the slope that we're looking for that one, I'm going to say up here, m equals up 4 over 8, which we can reduce down to 1 over 2. So if we want a perpendicular slope, so perpendicular m would be flip these around, and instead of a positive, make it negative. So negative 2 over 1. That says from whatever point we're starting at, go down 2 and right 1. So if I start here at B, I'd go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Continuing somewhere on this line, that would be my diagonal. I'm going to draw in that second diagonal then. So anywhere on this line would make a kite. The only spot that wouldn't actually make a kite is this one right here, because we already decided if it was right here, it wouldn't be a kite, it would be a rhombus. So we need to find another point then from here down 2 and over 1 that would still be going along with these this diagonal and make it a kite. So here to here, then we would have a kite. What would this point be? Again, this one kind of goes off the chart, but we should be able to see this is 6 over. So our x value is 6. And from here to here, we had to go down 2, so our y value is negative 2. If we plotted this point, 6, negative 2, right here, then we would make this into a kite. And that'll conclude our second video.